Welcome to Matthew Isaiah. Yeah, so this is going to be the continuation of circle geometry. We did 2 theorems. Now this is going to be the 3rd theorem. Now, very quickly, straight to the point. Now the theorem states that the angle subtended by an arc. Let me draw it. So this is a circle. Now this is an arc. So the angle at the center is 2 times the angle subtended at any point on the circumference. Now that is the theorem. I don't want to write it out. Angle at the center is 2 times the angle subtended at any point on the circumference. It can be like this. It can be like this. As long as it's subtended by this arc. This is what an arc is called. As long as it's subtended by this arc, whatever angle is here, if this is 60 degrees, then that means this is 60 degrees, and this is 60 degrees. It's as simple as that. So that's the 3rd theorem. Angle at center is 2 times the angle it subtends. Now the word subtend, if you break it down, is sub and tend. The word sub actually means under, and tend is more like extend. So the angle extended by this arc to any given point on the circumference is twice this, rather. So any angle here. So that means this is 120. So if you're given a question, for instance, and they tell you this angle is 70 degrees, what's this angle going to be? You just know it's 140, because angle at center equals 2 times angle at circumference. So that's it. For the 4th theorem, I'm not going to delete cancel all of this because they're quite related. Now, like I said, this states that angle at center is 2 times the angle it subtends at any point of circumference, right? Now for the 4th theorem, states that angles in same segment are equal. Now let me show you what a segment is, because it can be confusing because sometimes they don't draw out the chord. This is a circle. We all know this is a chord. I told you a chord is a straight line drawn to touch any 2 points on the circumference, but doesn't go through the center of the circle. The minute it goes through the center of the circle, it becomes a diameter. You understand that? Now, this is a chord. Now, a chord actually divides a circle into 2 segments. So we can have this as minor segment, and then this is major segment, because this is the bigger part, the major side. Now, angles in same segment are equal. So as long as it is subtended, the 2 angles are subtended by this, they are always going to be equal. So if you have this, or this, or this, or this, they are always going to be equal. So I didn't delete this because it's almost the same thing. It's just that for here, we are dealing with this angle. So in this scenario, for instance, it doesn't necessarily have to go through the center. You get the point? Just letting you know that angles in the same segment are equal. As long as they are subtended by this, they are equal. It's a rule. And then angle subtended by an arc is 2 times the angle. The angle at the center is 2 times the angle that is subtended at the arc. So these are 2 different rules that you might want to keep in your head. I didn't cancel this so you can see the relationship between both of them. For this, it's subtended by the arc. For this, it's subtended by these 2 points. Sometimes this is not always put there. Sometimes this is how you find it. But just know that this is the major segment, this is the minor segment. As long as they are subtended by these same points, the angles will always be equal. And as long as these angles are subtended by this arc, the angle here, 2 times the angle here will be the angle here. That's how it goes. Now this is theorem 5. We actually have 8 theorems in total. The last 3 theorems are on tangent, so I'll be talking about them in the next video. But then, the 5th theorem states that the opposite angles of a cyclic quadrilateral. Now you need to take note of those words. Cyclic meaning in a circle, quadrilateral meaning 4 sides. Now this is a circle. Now it says they are supplementary. Supplementary angles are angles that when you add them together, they make up to 180. So we can have 90 and 90. Okay, we can't have that. That's the right angle. We can have 80 and 100, 50 and 130. Those are complementary angles. So for instance, you have this is a circle. This is a quadrilateral in the circle. Now it says opposite angles. Opposite angles. These are the angles here, 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 here. So it's saying opposite angles in a cyclic quadrilateral are supplementary. So for instance, let's say this is an external angle here, and you're given here to be 60 degrees, and you're given here to be 70 degrees. Automatically, that lets you know that this is 120 supplementary angles, because when you add them together, you must get 180. So if this is 60, this has to be 120. If this is 70, this has to be what? 110 degrees. So this is what it means. Opposite angles in a cyclic quadrilateral are supplementary. I hope that clears it. So those are the three theorems that I'm going to be talking about today. In the next video, I'll quickly cover up the theorems that has to do with tangent, and then we're done. So basically, and I think at the end of that video, I'll then put a few questions and solve a few questions me on all of the theorems, so you see how to apply it, because one of the topics I love so much actually. I actually love every topic, but then my love for circuit theorem is beautiful, and I like it because people don't like it. A number of people run away from it because it's theorems, but it's beautiful to me. So yeah, this is the fifth theorem. I'll see you in the next video.